Hello, my name is David Nguyen. It's very late, but here is my AP daily video on thermodynamics. Thermodynamics is one of the heaviest units on the AP exam, so you better freaking study for it, okay? Because it's on there. One of the most important formulas that you need to know regarding chemistry and thermodynamics is this equation right here. Delta G is equal to delta H minus T delta S. So all of these variables are pretty simple. Delta G we'll explain later, but basically just know that it means this formula. There's some other formulas that relate to it, but this is what's most important. Delta H is the change in enthalpy. Enthalpy is the heat energy of a system. So if anything, releases some kind of heat or absorbs kind of heat energy, then there would be a change in enthalpy. T refers to temperature, and delta S refers to change in entropy. Entropy is the disorder of the system, and we'll explain that later. But to explain more, let's look at a student who actually used this on his AP test. Let's go.
What is delta G? Bro, what? How am I supposed to solve this problem? Wait a second. I have an equation inside of my head. I can use it on the thermodynamics test. Delta H minus T multiplied by delta S equals gives free energy. Yeah, this thermochemistry. I wanted the 5, but I didn't want to study. Oh well, guess I'll study enthalpy. Enthalpy is a system's heat energy. It can be absorbed or released to the surrounding.
Endothermic or exothermic, heat travels both ways. Where heat is transferred depends on delta H, but you will see it can get confusing, because temperature and heat also means energy.
Delta T, often used in calorimetry. Woo! Then multiplied by MC. 4.184 joules is water specific heat, raising the heat by a degree.
Exothermic because enthalpy is decreased. Now beginning to lose sleep. 1 sheep, 2 sheep, it's getting late and I need to sleep. But I'll do better than you think, cause I
have an equation inside of my head. I can use it on the thermochemistry test. Delta T times C and the mass of substance equals Q heat energy. Yeah, MC delta T, Mr. Devlin. Mr. Devlin.
Now I ain't much of a chemist, but I know the second law of thermodynamics and its entropy, how it increases universally and almost certainly, so I keep calculating. Chaos in the world is what will happen.
Yeah, high entropy, delta is positive, when entropy low is the opposite.
Oh, what am I gonna do? H is positive, but not S. Assume the reaction is non-spontaneous, and when these values are flipped. Delta G is negative, it's the converse, but we need more info when they're the same sign, because when they're negative, delta G is the same when temp is at low lines. At the same time, non-spontaneous at high temperatures, it flips temp when it's positive. I'm just using what the equation in my head says. I'm not a scientist, I
have an equation inside of my head. I can use it on the thermodynamics test. Delta H minus T multiplied by delta S equals gives free energy. Yeah, this thermochemistry, Mr. Devlin. Mr. Devlin.
Call me crazy, but H is so easy. With Hess's law, I'll calculate the reaction's energy. But until then, heat's reduced. I'm coming straight at equations. Heat gets lost and add the steps with the minus. Make it positive. Give every scaled equation enthalpy change and then multiply that by whatever you're seeing.
Its phase change got a different formula. The C or T, just laying heat to guide you from liquid to solid and back. Heat of fusion change state.
Freezing point. After is the latent heat for vaporizing. Turn liquid into gas is how we make that energy needed. No temp change because it's used in bond breaking. Concentration is breaking. Face facts. The test is today, but I'm okay with that. It's nothing because I
have an equation inside of my head. I can use it on the thermochemistry test. Delta T times C and the mass of substance equals Q heat energy, yeah, MC delta T. I have an equation inside of my head. I can use it on the thermodynamics test. Delta H minus T multiplied by delta S equals Gibbs free energy, yeah, this thermochemistry. Mr. Devlin. Mr. Devlin. Uh-oh.